Hello everyone! Today we are tackling a classic calculus problem, finding the area enclosed between two curves. Specifically, we have a parabola defined by y equal x squared minus 6x plus 8, and a straight line defined by y equal negative x plus 4. To solve this, we need to follow three main steps. First, find the points of intersection to get our limits of integration. Second, determine which function is on top. Third, set up and solve the definite integral. First, we need to find where these two graphs meet. These points will become the boundaries for our integral, our a and b. We do this by setting the two equations equal to each other. X squared minus 6x plus 8 equal negative x plus 4. Now let's solve for x. We want to move everything to one side to set the equation to 0. Let's add x to both sides and subtract 4 from both sides. So now we have x squared minus 5x plus 4 equals 0. This is a simple quadratic equation that we can factor. We need two numbers that multiply to positive 4 and add to negative 5. Those are negative 4 and negative 1. For our first root, we will set x minus 1 to 0 and we get x equals 1. For our second root, we will set x minus 4 to 0 and we get x equals 4. So, our intersection points are at x equals 1 and x equals 4. These are our limits of integration. Before we integrate, we must know which function is the top function and which is the bottom function in the interval between 1 and 4. The formula for the area is the integral of the top function minus the bottom function. If we look at the graph, or if we plug in a test number like x equals 2, for the line y equals negative x plus 4, we get negative 2 plus 4 equals 2. For the parabola, y equals x squared minus 6x plus 8, we get 4 minus 12 plus 8 equals 0. Since 2 is greater than 0, the line is on top and the parabola is on the bottom. So our setup is negative x plus 4 minus x squared minus 6x plus 8. Be very careful with your negative signs here. We are subtracting the entire parabola equation, so keep it within the parenthesis at first. Let's simplify the expression inside the integral before we do the calculus. Distribute that negative sign. So we get negative x plus 4 minus x squared plus 6x minus 8. Combine like terms. We have one squared term, which is negative x squared. Let's write that down. Next, we have two x terms, negative x and 6x. So 6x minus x equals 5x. Let's write 5x next to negative x squared. Finally, we have two constants, 4 and negative 8. So 4 minus 8 equals negative 4. Let's write that also with the above. Now, we set up the definite integral from our lower limit 1 to our upper limit 4. A equals the integral 1 to 4 of negative x squared plus 5x minus 4 dx. Let's find the antiderivative using the power rule. For negative x squared, it becomes negative x cubed over 3. For 5x, it becomes 5x squared over 2. And negative 4 becomes negative 4x. So we evaluate negative x cubed over 3 plus 5x squared over 2 minus 4x from 1 to 4. First, we plug in the upper limit, 4. So when x is equal to 4, we have negative 4 cubed over 3 plus 5 times 4 squared over 2 minus 4 times 4. This is equal to 8 over 3. Next, we plug in the lower limit, 1. So when x is equal to 1, we have negative 1 cubed over 3 plus 5 times 1 squared over 2 minus 4 times 1. This is equal to negative 11 over 6. Now, let's subtract the upper limit from the lower limit. 8 over 3 minus negative 11 over 6. So, the area of the region enclosed by the curve and line is 9 over 2 square units. Remember, if you ever get a negative answer for an area problem like this, check to see if you accidentally subtracted the top from the bottom instead of the other way around. Thanks for watching. If this step-by-step breakdown helped you, please hit that like button and subscribe for more tutorials.